Still going live. I see. I am live. Okay. But still. Come on. There we go. Let's make sure this is off. There. Cool. All right. So it went less wrong than the first two times today. It's good. Making progress. So, oh, it doesn't have my. This is, so you can scan this, but I'll put this link in Husky CT as well. But if you want to get to like my main website, it's at cooperrc.github.io, and I'll show you this website in a second. But that's where you can go for like office hours. So I don't have like a block of time each week, but if you have questions about like where are we going with this course, or does this connect? This feels like we're doing so much math. Why is this even engineering? How does this connect to my career? Any of those kind of questions, or if it's just like a general question of like, this seems like I could do something like this in whatever, like building submarines or trying to build aircrafts, like go work for Pratt & Whitney and build aircraft engines. If you have those kind of questions, I'm happy to sit down and look at like, where does our work parallel where you're trying to go? Like, how is what we're doing now actually related to your career? But that's the first thing. So if you go to that link, then we end up at this webpage, and this is me, Professor Ryan Cooper. This is Applied Mechanics 2. It used to be CE 2120. Now it's ME 2120, a whole new rebrand for the School of Mechanical, Aerospace, and Manufacturing Engineering. This is the foundation of all of that stuff, like aerospace and building stuff and making things work. Lots of WD-40 and caulk, you know, like getting things the way you want them. And again, this big link right here, that Calendly link, grab that anytime you want to meet. If you have questions, comments, or like some kind of help, career or course, either one, it's great. And we're down here. It's still labeled CE 2120, but the content is ME 2120. That's us. Applied Mechanics 2, Engineering Dynamics. Everyone's still in the right course. Wrong classroom, right course. It feels hot down here. Just me? No, it's hot. Maybe this will be nice in November. It'll be like when we got the warm room. I guess before I move on, what is this course about? Why are we here? Does anyone know what the course? There was Applied Mechanics 1. Why a 2? What's with the sequel? Yeah. Not everything's static. So number 1 was sum of the forces is 0, right? Now, get ready for it. It's MA. Sum of the forces is MA. And sometimes that MA stuff is moving, but the change in momentum is small enough that we can still say sum of the forces is 0. But everything's moving still. So a lot of that's called like kinematic work, where we just care about the geometry, how things are connected, are they going to overlap, do we have enough degrees of freedom, do we have too many degrees of freedom, those kind of problems. And there, everything we did in Applied Mechanics 1 is directly transferable. and then plus you'd stack on a whole bunch of other skills on top of that. But then the other part, whenever we get into F equals ma, so now your momentum is an actual force in your sum of the forces diagram. Now things are changing. It's like, well, that was my free body diagram, but now it's different because everything moved. It A'd somewhere. Accelerated. All right, so then I'll talk a little bit about this course. This is going to be probably hard to see. Let's zoom in. It'll be a flipped lecture format. So all the readings and like previous videos, and there's a whole bunch of information that is kind of curated and collected within Husky CT and this main like open educational resource. All that stuff I expect that you review, or at least you're aware of, that you can go back and check at some point during the semester. The expectation is that you're kind of following along as we're going from one module to the next, watching videos, trying practice problems on your own time. And then when we get to class, we can work through homework problems and kind of like troubleshoot how to do specific things that we're trying to do. That's like the main goal there. How does that sound so far? Have you been in flipped classrooms before? Okay, so this is just me mansplaining flipped classrooms to you. Okay, great. We're off to a great start. So I could have just said this is a flipped class and just skated on through. All right, next time. So this course is all hosted on GitHub, or like the course resources are on GitHub, and one of the reasons for that is we can have GitHub discussion board, where this can be our offline, like or kind of online asynchronous question Q&A. Like if you're trying to work through a problem and you're stuck, or you think you have an answer and you want to post something there. Just as a word of caution, this is an open like discussion forum, so don't put like personally identifiable information on there, but anything like content wise is free game. Like if you're asking about the course, even logistics about the course, like if it's like, hey, there are 2 problem 1s in homework 1, can I just do one of them? Like, no, that's just a typo. Do both, please. Like those kind of questions are great. Any of those. And you can even go through and see like what other people had said about the class. So all that previous knowledge is still transferred into current course. Main course material, UConn Library hosts our engineering dynamics textbook. So in any of these links, if you click those, you can download the PDF for the textbook. If you prefer hard copy, you can buy this Kasdan and Paley hard copy book, but it is available as an electronic resource for free. And then we'll use this website for our projects and homeworks and those kind of things. This is all like the fun logistics stuff. Everyone's very excited about going through the mechanics of how to learn mechanics, applied mechanics too. And you saw me struggling with YouTube to get started. There's previous year's YouTube content, which is on my UConn Google account, which was run over by a truck over the summer and scattered everything to the wind. So I don't have access to the old channel, but I have a new and improved YouTube channel, and you can watch these recorded streams there. You can join the live stream through there, and the chats are open, so you can ask questions as we're running. If we're in class and you see someone asking questions, like, you feel free to like stop me, because it's hard to manage online and in-person questions at the same time, and I'm also easily distracted. But yeah, that would be great if anyone is like, hey, look, they're asking you a question. I'm like, oh yeah, that is relevant. Sometimes, I mean, I guess some questions might not be relevant, so we don't have to stop for everyone. Like, Professor Cooper, someone random on the internet wants to know if you want pictures of something and something. It's like, maybe that might be relevant. We don't know. We don't know what kind of pictures they want to sell. And yeah, rather than keep going through. So I was showing parts of the syllabus here. And in Husky CT, hopefully you see the same thing that I do here, of like different modules. Module 0 is just sort of like our first week, getting to understand like how we turn things in, what we're doing. It has our first quiz. This is the only quiz that's online right now, because as we get into modules 1, 2, 3, and 4, we'll build the quizzes together. So based on the homework that we do, the discussions that we have in class of like what resonated with this specific class, like what were topics that were interesting or what were different variations of things that we already did, then we'll build the quiz together, and then I'll post that PDF online, and you can submit that through those quiz, like the submit quiz link. Like this one, this is our first quiz. So we have, in our first quiz, there's an image of Spider-Man, like carrying this bad guy through New York City, and you're asked to draw a free body diagram of Spider-Man swinging. And there's two things, and then also the second part is write down Newton's second law of motion. So just two different types of questions. Free body diagrams are big in this class. Yeah, go ahead. If you want to consider, I've seen both. And this one's like kind of gauging where you're at with free body diagrams. So I've seen people do like try to get a perspective drawing of 3D motion. But you can kind of project it onto a 2D path anyway, unless you want to consider like two different ways of centripetal acceleration. But yeah, I've seen both. No, 2D and 3D are both fine for this. And yeah, do we want to let's do this, since we're having a free body diagram discussion right now. Let's say my answer is let's say my Spider-Man free body diagram is there's the force of the web and the total weight. Is that good enough? No? Why not? What's missing? Like, am I missing something? Is it? It seems like there's got to be more. Like, because this is like just hanging by a web, but he's moving. Yeah? Okay. So it feels like something's missing. And this could be 2D or 3D, right? Because if both of them are in a line, then no matter how I look at it, it's kind of two forces that are equal and opposing each other somehow. So then really the question that I kind of think about when I'm thinking about free body diagrams is, what is the question that I'm trying to answer with this free body diagram? Like, it's a tool that I'm using to try to understand something. So if my question is like, what is the minimum force that the web is holding? Minimum, the very minimum. So then the answer to that would be like, well, it's got to at least hold the weight of Spider-Man and the bad guy. So I could have some total W, and the web is the only thing holding the two of them up. So in that case, it does answer that question. Like, what is the bare minimum of like, what can this web hold? So it's not, but I think your intuition's kind of right. Of like, it feels like something's missing. Because also, the web is not straight up and down, right? And the weight is not down. It's more something like this, right? F of the web and the weight down. Like a total weight straight down, but the force of the web is out that way. Is it better now? Kind of? Yeah. Sorry? Something force forward? Why is that? Momentum. Yeah, so the momentum, we can, so most of the time we say sum of the forces equals MA. Like the vector, the total vector force, when I add all the vectors up, that equals my A vector, but times whatever mass I had. There was one guy, I think it was L'Hopital, who said sum of the forces minus MA equals 0. Mind blowing, right? And in his free body diagrams, all the momentum forces are like negative acceleration terms. Like I could draw, I think it would be something like this, like a negative M centripetal and a negative M like transverse, something like that. Like I could draw the MA terms in the free body diagram, but I would have to draw the opposite vectors somehow, or draw them positive, but remember that I have to subtract them. So instead, usually we stick to like this frame and say all this is equal to, like, and I could draw acceleration however I want. I know it's a vector, so I could say like MAX, MAY, and now those terms, like all that extra inertia stuff, is all captured in this new diagram called the kinetic diagram. And then I don't have to worry about like, is it positive, is it negative, does it have to point this way or that way, because it gets confusing enough as it is. But yeah, thanks for asking. Yeah, and here, like if I wanted to consider this as like a 3D motion, like maybe I would have MAZ, MAY, MAX, and I think I would still only have web and weight though. Like even if I'm moving around in a three-dimensional kind of path, it's just I would have 3 components of acceleration that way. But cool. And then, yeah, so once you go through your free body diagram and kind of your answer, the other part of the quiz that I like to have you do is record yourself for like 10 to 30 seconds about like where you think you're right or where you're like missing something. So it can be audio or video recording, but something that you like talking about your quiz. Doesn't have, it's not like a long step-by-step solution. It's just like a check-in, like what makes sense, what doesn't make sense, something like that. So if I was doing this, let's say I was submitting this answer of like 3, 2, 1. Hi, I'm Ryan Cooper, and this is my solution for the first problem in the quiz 0. I think there are only 2 forces acting on Spider-Man, but I do think there could be 3 components of acceleration, but I'm not sure how to draw that yet. I haven't practiced it in class, so this is something new to me, but I thought that sum of the forces is MA, so I put it in 2 separate diagrams. And that would be like my quick 10 to 30 second. What's the elevator pitch of like, yes, I understand this, or no, I need some help, or like I'm just wildly guessing. I drew some arrows because I think arrows are part of diagrams somehow. And either way, wherever you're at, I just want to know what's going on. Cool? Pausing for a second. Other questions so far? Just cramming through logistics of the course. Some quizzes so far. Then homeworks and projects. So quiz you'll do at home. That'll be like a time for you to look at what we build as a class for the quiz and then create your own solution. And then the homeworks and projects we can work on together in class. And at the top of each module will have like what readings and videos are connected to the homework, the quiz, the project, like how is that all, what is supporting this, like these activities that we're trying to do. So like here's the module 1, chapters 1, 2, and 9. Chapter 1 is pretty short, but chapter 2 and chapter 9 are like longer chapters. So I always give like some kind of focus on steps. Like if you just take a look at these examples or tutorials, it's usually a good place to get started. And then if you want to dive deeper into anything, then there's further resources in the textbook. All right, let's do something fun then. All right. Does anyone have a problem with F equals MA? Like, does anyone fundamentally disagree with forces equals changes in momentum? That the force is the cause for that, like the effect of a change in momentum? I'm trapping you, but you can say that you have a problem with it of like, well, it doesn't take into account relativistic effects, but it sounds like, at least from the sound of nothing, that there are no concerns of relativistic effects. And sorry? No, this is, I mean, it's super accurate to the point of like, as long as you're not traveling like 99.9% of the speed of light, you're good. And as long as you're not about the size of like an electron, like or a little smaller than an electron, like if your mass is smaller than an electron, then you start having some trouble. Or if your mass is like bigger than a black hole, then there's also problems. But otherwise, like you can use F equals MA to predict all sorts of stuff. Like you can go to the moon and back and like create models for all sorts of different stuff. But those are, and also like time scales. So if you're talking about like, I want to watch this thing, I want to create a model of this thing happening, but I want it to happen over thousands of millennia, then also you get into like relativistic kind of effects. But most of the stuff, like throwing a tennis ball off a building, totally F equals MA. Yeah, all sorts of stuff. Works pretty well most of the time. Okay, so every action has some equal opposite reaction, right? and still no issues with Newton and his laws. So if that's the case, so if every action is because of some other action, can you still have free will in that case? Like, can you make a choice? Or are things not, is it not a causal reaction, something else happening? And you can I'll hand out some note cards, like write down what you're thinking. Sometimes it just helps you write. Or if you have like immediate issues with this, you can always shout it out, like, blasphemy. Of course there's free will. So what do you think? If every action is based on some other action, can you still have free will? Do you think yes? Do you think no? Did you used to think yes, but then this class totally changed your whole worldview, and now you are a deterministic automaton moving through life based on other people's actions? Yeah. Need more? Are there more? There should be. All right, sweet. They're coming around. It's out of my control. Still more? More of a practice. Like the writing is the exercise. You can do. If you want to document it, yeah, it's yours. Yeah. Well, it's based on previous actions. Still have free will. So then, how does something new happen? Yeah. So can we create energy? Shouldn't that be like a free energy creation? If you can create force out of nothing, it's just kind of philosophy. Philosophy. Yeah, and like scientists jump through a lot of things. The brain, chemical reaction, the muscles are electrical, and all that is like invisible, and they kind of stuff happening. Always a cause. Like what makes it a free decision, not based on previous I'm not saying you're wrong or yeah, like I don't have an answer, but as devil's advocate, deciding to come to class is probably based on years of people telling you you're in class and being successful because you're in class and now missing class. Yeah.
Anything goes. You know what I'm saying? Like we're just like affected by like years and years of like social stuff or all that, and it's like, yeah. That's internal. That's been great. Some of that. But even like the times
Or are you thinking? So are you saying like free will as an independent object or
I mean, you could think of it like, does this text loss? And then you could do all sorts of measurements and say like, no, it does not. Because you never had a choice other than proceeding based on physical constraints. So then if you put a mirror up, now you're like, so I have free will. So put yourself through the same experiment. If I fall off the chair, I'm still going to accelerate. Regardless of what I'm thinking about or what my free will is trying to do. So is that enough to say like there is no free will?
I said it like just the two roles response to your choices.
A response?
Yeah.
Okay. Yeah. But there's
You can kind of choose what effects like forces on you.
yeah.
If I wanted to fall, I have free will to make that fall.
Okay. So can you create like free energy from that? Like can choice lead to free energy? So like in thermodynamics, the perpetual motion machine is a machine that when you turn it on, at first it took energy to turn on, but then it never needs energy again. Yeah, like it'll just always run forever. You never need to recharge a battery. And that one is something like if you get into patent law as an engineer, your main goal is making sure that no one gets a patent for a perpetual motion machine because there has to be an entropy generation from a machine, like anything that's going. You can never have energy just go around in a cycle and never lose anything. So if you have, like if you're saying that your forces can be created just based on a choice, a force through a distance is energy. So could you just create that and have free, unending sources of energy? Just keep making choices and keep getting free energy. Yeah. Maybe.
You mean like the energy is like, it's never mind. I don't know how to explain it.
Yeah. But like myth of Sisyphus, he's like perpetually rolling a boulder up a hill. That's a lot of work. So if someone was like, every time he let the boulder go down the hill, they like sucked up that energy and charged a battery. Now, if he does it forever, then based on his choice to roll the boulder up the hill, you have all these free batteries that you can start selling to people. But, oh, you know, it's for you. It's a thought process. Still free will.
So like if you fall out of a chair,
Alright.
no matter how much
Do you think chaos is a choice?
So like can you control that? That's an uncontrollable.
Alright, so there's one thing that came up that I did want to share, like chaos in motion. Let's see if this one still works. So like have you seen double pendulum kind of experiments? This is a great example of like the simplest version of chaos. Of like for a small change in initial condition, you get a very different final position. Like if you go from 0 to 3 seconds and you start one at whatever 0.0001 radians away from the other one, like not even a measurable amount of distance difference, then the end result is very different than the initial starting. And both of them have different results. So let's see if hopefully the animation still works. Here we go. All right, so this is like 100 different double pendulums. They all started at what looked like the exact same position, but then as time goes on, they're all changing. Like everyone starts to diverge and end up in a different location. And these pendulums are all directly following Newton's laws. There's nothing that is not Newtonian physics in here. And it's like pure F equals ma Newtonian physics. So every motion is the result of a previous force from the previous time step. So like thinking about like how many different variations there are of these double pendulums, some people that don't believe in free will point to chaos and say, look, you can have what looks like freedom without choice. None of these pendulums had a choice to be in a different location, but they all ended up in different places. That one's kind of weird, right? Yeah, but so this one people kind of use, they try to use it in both ways of like, yes, we have free will because chaos is a thing, but also people are like, yeah, but chaos follows Newton's laws, which means every action is the result of a reaction, and every reaction is some action. So there's nothing free about chaos. So who came into class because they thought it was like free will is my life, like free will. I'm definitely like free will is a thing, and I have free will, and so were there a lot of people? Did a lot of? I guess we could do like thumbs up, so you don't have to like feel outed. You can kind of hide it. Thumbs up. So did anyone feel like no, like free will has always been an illusion? Like I'm trapped by the system. That's a whole different, separate issue about like the system and how it's, yeah. Any of those? Any like thumbs down of like I'm just a cog and I got to go through these motions because. Did anyone change throughout this discussion, or has it just reinforced your opinion so far? Reinforce, yeah. So far, the kind of arguments that I've heard as I kind of checked in so far was one kind of group of thoughts was, well, I thought I had free will, but it seems right that there's just everything is just the result of previous action. So maybe there is no such thing as free will. That was kind of one group, and I'm like summarizing, painting with a broad brush, and you can correct me. Please do correct me if that's like not representing what we were talking about. And then the other group was kind of like, well, Newton's laws work, but it's not me. Like I'm not a falling tennis ball. So there's something different about me and free will. Like I have free will. The stuff that I'm studying and working on equations for, that maybe that doesn't, or maybe it does, but that's Newton. This is me. I'm not a Newtonian object. So it's like roughly. Did anyone have a different thought or clarification there? What were you thinking? I didn't get to this half. Did you have different thoughts? No? It's hard to like speak up. But you do have the choice. Was that it? Did that cover everybody? I can't. That was too broad. I put you into two like very different bins. Or two bins of just either ignore Newton's laws or accept it as your fate. So we either have people that believe in fate or people that just stand in opposition to fate. Is that it? Is everybody? Are we almost at time? Is that why we're like quieter? Is it almost time? Wait, when did we start? 12:20. We got 10 minutes. We still got 10 minutes. You can start a discussion. Nobody will be mad at you for starting a discussion now. Still got 10 minutes. Yeah.
Well, my opinion was like ultimately we don't have free will because I think we're all a combination. Our choices are influenced by the people around us, by like
Yeah.
the history. Like I feel like we think we're making decisions on ourselves, but like I think we're just influenced by like social norms and just
Yeah.
like a bunch of different factors.
Yeah. Yeah, there's a lot of stuff that is a factor of like culture, family, the people that you've been around, or being like from a different culture in a new culture. Like there's a lot of things that are going to affect how you work, like the things that you do. Yeah.
Kind of going with what she's saying, I think free will is nullified only because we're all controlled by like aspects of power, which is like money, right?
Yeah.
Or influence.
Yeah.
So at the end of the day, like, realistically, a lot of us are here just because we want a paycheck at the end of the day. So.
Okay. Yeah. Cream. The cash rules everything. Gotta get the money.
I think we all have some free will, but like want to make money, you can't just really come into business.
Yeah, you can't be like, you can't just make the choice to have money. Okay.
Even though that I'm in science,
Yeah, then like choice, right? Like having some factor of choice in that way. Yeah.
Just building off of that, same thing. I feel like we do have constraints, but within those constraints, some sort of free will to a sentence.
Okay. So maybe, and I'm kind of framing this in the course of like why even talk about this in a like very physics and math heavy course of like these are a set of tools and like constraints that you can set on you could set it for your life of like, yes, I am a robot, I am a Newton robot, and like that's the way that you think about yourself and your life. Or maybe you're kind of stepping back and thinking about this as like, this is a super helpful set of tools. Like as a carpenter, you have all these different tools that help you build wood, but you're not going to do like surgery. You're not going to do bone surgery with your wood tools. You have a very different set of tools for that. This is like a framework for understanding mechanical systems, like things that are moving and connected or orbiting with gravity or Coulomb forces. So that might be like one way of reframing this class of like, yeah, the things that I build don't have free will, but maybe that's separate from the way that I'm thinking about my life and my choices and things that I do. It's not a tool to use on myself. Cool. Thanks. Are there issues with free will? You're just moving on. But this idea of like free will and determinism, a lot of times we don't really think about it because it's just so common in the physics and engineering kind of progression of like, okay, we need to know how things fall. Well, F equals ma, ma equals mg, so a equals g, and here's the equations to solve for position like of a falling object. But baked into that is this like dogmatism of like that there is that there's something controlling, like there was the unmoved mover that set everything in motion and created these perfect laws of physics, and like everything is going to follow this system that was set up by, again, like some kind of architect. And whether or not you believe that is also like up to you. But I like to think about it. And I think for next time, we'll make a plan for coming lectures. Next time, we don't need to review any of like the module 1 stuff, but we'll work on the module 0, like first homework assignment. So we'll fire up some Jupyter notebooks and start working on that. If you've used Python and Jupyter before, then this will all be review. If you're like, what's a Python, what's a Jupyter, then that's okay too. I don't expect anyone to be like coding experts even from the experience that they get in this class. It's more that you can read and interpret things and use code to like make some new insights into problems like that. So that'll be like Wednesday, try to fire up some Jupyter, move into that. And then Friday, hopefully wrap up like our getting started kind of work. So if there's questions about how the class is going, bring them up Wednesday, Friday, and we'll cover those. Sound good? Cool, thanks.